Measures of center. A measure of center is a value at the center or the middle of a data set. Mean, median, and mode are all examples of measure of center, or in other words, 3 different ways that data can be analyzed or described or represented. So here's a set of data. We could pretend, for example, that this was ages of people at a party, and we could describe this data in at least 3 different ways. We could say that the mean of this data was 47, the median of this data, the median age of the people there was 51, and the mode was 62. So let's see how we find each of these measures of center. First, let's talk about mean. The mean represents a fair share concept of the data. It's often called an average, which you've probably heard of before. Average and mean are used interchangeably. The way to find the mean or the average of a set of data is to do the following. Add all of the following data points and then divide by the number of data points that you have. So here's an example. Let's say that you had 2 tests. The first time the test, your score was 82, and then I let you take a retake and you got a 96, and I told you that I would average the 2 numbers to get your real score that I would put in the grade book. Well, what I would really do is add those 2 scores up, 82 plus 96, and get a sum of 178. And then since I have 2 tests or 2 data points, I'm going to divide by 2, and your average or your mean would be a score of 89. And the reason that it says up here that it's a fair share, we always talk about fair share when we're dividing, so there's where that comes from. But here's a picture of it. You can see 82 and 96, and that we are sharing them, sort of meeting at a midway point in 89. And you can see with just 2 data points, it's easy to see that the mean represents a number right in the middle of the data points that we have. So it's a fair share halfway between either of those data points. Here's a second example. We have the numbers 5, 9, 13, and 21 in our data set. I added all of these up to get the sum of 48. I had 1, 2, 3, 4 pieces of data, so I'm going to divide by 4, and my mean or average was 12, because 48 divided by 4 is 12. Our second measure of center is median. The median is a piece of data that lies in the middle of the set of data when it's arranged in order. It's important that you arrange your pieces of data in order before you, from least to greatest, before you ever find the median. So here's a set of data, some amounts of money. Maybe these are the amounts of allowance that people get when we took a survey. So the first step is to put them in order. Here's 1. I'm going to cross those out as I use them. 3, 4. Then I have a 6, a 7, and 2 8s. I'm going to represent both of those to make sure I don't lose any data points. And then I'm going to find the number in the middle of this list of data. So you can just even work in with your fingers. Outside, the next 2, the next 2, and the 6, you can see, falls right in the middle, which makes sense. In 7 pieces of data, that number 4 would be my center or my median piece of data. So 6 is the median of these numbers. Here's another example. I want to first get them in order. So I see 9, 2 11s, 12, then 16, 17, oh, there's a 14, 16, 17, and 19. All right, now I'm going to work my way in from the outside. Last 2, next 2, next 2. All right, I have 2 numbers here that fall in the middle, and this may happen in your data points. When you have 2 numbers in the middle, you need to do one more step. The median is going to be the mean of the 2 numbers. So go back and think about what we just said about mean. You're going to add the points. 12 plus 14 is 26, and then divide by the number of points, which would be 2. So 26 divided by 2 is 13, which makes sense. It's the number that falls right in between those two. So the median of this set of data is 13, and I found that by finding the mean of the two middle numbers. The mode, our next measure of center, is the piece of data that occurs most frequently or most often in the data set. It's important to know that could be different amounts of modes based on your data set. Sometimes there may only be one mode in your data set. Sometimes there may be more than one mode in your data set, or it's possible that you may have no mode at all. So let's look at an example for each of those. In this set of data, I'm looking for the value that shows up most frequently or most often. And I see here that I have 2 of 285. So the mode, or the number that shows up most often, that shows up most often is 285. In this set, I'm going to look and see for any repeated numbers. And there are no repeated numbers. So there is no mode in this set of data. Each of these data points only occurs one time, so there's no mode. In this set, I have decimals, and I have 4/10 twice, so that's a mode, and I also have 3/10 twice. So this set of data has two modes, 3/10 and 4/10. One more way to describe data that's not really a measure of center, but falls under the same analysis of data is the range. The range is the spread of a data set. You will find the range by finding the difference between the greatest and the least values. So in this set of data, I'm going to look for my greatest data point, which is 20, and my least data point, which is 8. And then I'm going to find the difference, which means to subtract. So 20 minus 18 is, I'm going to borrow, 10 minus 8 is 2, 1 minus 0 is 1. The range of this set of data is 12. Just did that by the greatest minus the least. So let's put all of that together and find each of those ways to describe data using this set of data that's been put in a stem and leaf plot. So I'm going to find the mean, median, mode, and range for my bowling scores that are arranged here. When I'm getting ready to find the mean, you're going to add up all the values and divide by the number of values that you have. So I went ahead and did that here. I listed all of my values, just reading 71, 73, putting that here. I got a sum of 774. Then I'm going to count my number of data points and divide by that number. One way you can do that is by counting the leaves in your stem and leaf plot. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 data points, which shows why I'm going to divide by 9. So 9 can't go into 7. 9 goes into 77. Let's see. 9 times 6, 9 times 7, 9 times 8 is going to be 72. I'll get 5 when I subtract. I'm going to bring down a 4. 9 goes into 54 6 times, and then 6 times 9 is 54, so I'd have no remainder. So my mean is 86. If you had a remainder, the best thing to do is to keep going, add a 0, a decimal and a 0, and get a decimal, and then you'd want to round to the same place value, most likely, that your data had been given in. So in this case, you would have rounded to the nearest whole number. The median is my number in the middle, remember. So I'm going to look at my data points and work my way to the middle. Here's the outside 2, next 2, next 2, here. So 87 is the number that falls in the middle. I could check that by remembering that there are 9 numbers, and the middle data point should be the 5th one. 1, 2, 3, 4, 5. 4 on that side of it, 4 on that side of it. So the median is 87. The mode is the number that shows up most often, and I see 2 5s here, which represents 2 95s. That's the number that's repeated, so 95 is the mode. And finally, I get the range by doing the biggest minus the smallest. 97 is the biggest, 71 is the smallest. When I subtract, I get 26. So the range of this data is 26.